Well, as I alluded to at the end of my last video, this one is going to be a combination of swapping out and reprogramming the inverter. This is the new one, made by Westinghouse. The manual telling me how to program it is not real thick and full of fine print, but there aren't that many parameters that have to be changed from what I've been told. Most of them are real close, and if I have any problems with that, Bob said he'd walk me through anything necessary, so we'll take care of that when the time comes. I'm actually going to do this part of it last. The first thing I'm going to do is this. It's called a conduit body. This is a 1 1/4 inch. The article online said he got his stuff from Home Depot, which is where I got mine. And he used a 3/4 inch, not a 1 1/4, but it was the old square style, and it happened to fit. The screw holes for the cover were a perfect match for putting the panel off the Powermatic straight onto here. Well, the 3/4 inch now is rounded like this one, and it's just not big enough. At least in my mind, it wasn't big enough. This looked to be a little better. The new screw holes will be right here holding the panel on, but that's not a big deal either. And I've got this. I was really hoping they had what they call a LL or an LR. LR means that this comes out the side instead of the bottom. If it goes out either the right or the left, wouldn't have bothered me at all. That way this would have been flat, and when I mount this big magnet I could mount this big magnet to the bottom, and then it would stick. As it is, this is going to be in the way. I suppose I could shorten it, and I may put a spacer in here and mount the magnet down here. I haven't decided yet. This is a 1/2 inch compression fitting. I'll run the cable through that, and it'll screw in to this bottom piece right here. The only thing I didn't get locally is the cable. This is roughly a 1/2 inch in diameter, which is perfect to go through this, and it's 25 feet long, and more than I need, but based on the price, if I got it locally, I'd have been paying the same amount. I paid $25 for this on Amazon, about $1 a foot, which is what you're going to pay. This is 14 gauge 7 bundle wire, so there's 7 color-coded wires inside here. I only need 5, but you can't buy 5. Sometimes you get lucky and find 6. I couldn't find any of that either. Without further ado, and without more rambling, I'm going to get my PVC glue, and I'm going to glue these pieces in, and then I'll start making modifications here, and we'll take the camera around to the front of the lathe, and I'll show you what we're doing. Well, it turns out I was wrong. I think I read that I only needed 5, but in all actuality, I need 7. Now, before we get to that, one of the things that blows my mind about this, and I'm not real sure why they did it, these are put together with wire nuts and wrapped in electrical tape. I would have expected something a little more professional than wire nuts and electrical tape, but that's just me. See what I mean? Wire nuts and electrical tape in 2 places. And as it turned out, I don't just need 5 wires. I need 7. There's 1, 2, that's red, gray, let's count them. Red, gray, yellow, white, green, black, and blue. That's 7 wires. So I've got 7 wires in the strand. That's a good thing. Now what I need to do is take me a measurement of how much of that 25 feet I'm actually going to need. The wire will feed out the back. I'm going to run the wire through the back where some of the cabling already goes up to here. And I'm going to tie into these with spade connectors just so I can unplug them later. I could just barrel crimp them and be done with it, but I think I'm just going to use insulated spade connectors and not worry about it. These are low voltage wires anyway. So I'm going to run the wire through the back, stick the loose wires out here so I can work on it, and then I'll just tuck them back inside. The panel will come off. So what I will do is I'll drill a couple of holes in here and tap this plastic to accept this panel. So this will just bolt right here. I'll screw it on here and the wire will come out the back. And then I can put this anywhere on the lathe I want it, just like the box for my 2014. The article also said that this hole was just big enough to put this 1/2-inch wire through. I'll believe that when I see it. This wire is just under 1/2 inch in diameter, and I don't think there's any way that's going to go through there. Let me see what I can do and I'll be back. Well, somehow or another, I don't know if it was in the move or if they're packed and I just don't know where they are, or if one of my sons borrowed them and never brought them back, but I can't find my good crimpers. So I've got a pair on order. They'll be here tomorrow. And you know, that's just about par for the course these days, 2020 and all. Anyway, got crimpers on the way. In the meantime, I've taken pictures of this so that I can take some of this apart, and I'm going to print labels for like the red and the gray wire that goes to white and black up here. That goes to the RPM panel, and this green and yellow goes to these two whites over here to the potentiometer to turn the speed up and down. So I'm going to go print a couple of labels so I can label these two white wires to what they actually go to, and this white and black to what they actually go to. And remember, I've got 7 wires that I need to deal with, and all of the colors correspond. White to white works fine. Green to green works fine. Yellow to yellow works fine. Blue to blue, gray to gray, and red to red. That leaves the purple wire. This bundle doesn't have a purple wire, but it does have a black wire right here that connects in conjunction with the yellow wire and the white wire from the potentiometer. So this purple will be hooked up to black. Once I get that unplugged and I can work with it, then I'm going to draw it out. I've already drilled my holes for where the mounting screws go, and I'm going to cut this out so that that will fit down in it and the wires will go through. I will cut a hole in here just big enough for all of that to fit in, and then I'll screw this down. Okay, I roughed that out with my air saw. So now I'm going to clean it up. And that didn't take long. And that, boys and girls, will do it. See, it don't go through. The holes are in the right spot. Now I'll cut me a piece of mouse pad to use as a gasket around here. That thin stuff, that old thin mouse pad, I got tons of the stuff. I decided it would be better for me to remove this inverter and hook the new one up and get it at least running, maybe not programmed, but at least running, so that I can, when I make the wire connections on the other side to my remote, I'll know that everything's working over there the way it's supposed to, so that when I hook the remote back up, I'll know, rather than having to do a lot of troubleshooting if something's not right somewhere. Work smarter, not harder. I've taken the connections loose from here. This red and gray wire that goes to what I think is the LED readout on the front. That's where the wire goes. It goes up that direction. So I'm thinking that's what that is. And these wires go to the brake resistor. So let me get these out of the way now. I don't know what y'all can see and what you can't, but I've taken pictures and I'll put those up. If you want to make sure that you keep a screw on the end of your screwdriver without dropping it, put a magnet on the back of it. It'll temporarily magnetize the... That's the wiring undone on the old one. Now I'll get an Allen wrench and take the box off and then figure out how I'm going to mount the other one. Okay, the box is off. Somewhere in there is a bad part. And it's probably a capacitor based on things I've read. The bolt holes don't line up, and I've got 2 options. Option 1, actually I've got several options. One option would be to drill and tap new holes and mount it, and I don't know that I want to do that. Another option is to use the original mounting screws and a plate. Screw a plate on here and bolt this to the plate. A plate made of what? Well, you could use anything. I can use scrap plexiglass, I got plenty. I can use wood, got plenty of that too. Or, I don't even have to do that. I can just mount it to a chunk of wood and bolt it to the wall. Then I'd have to rerun a bunch of wires because these aren't going to be long enough. So what I think I'm going to do is I'm going to take me a piece of plexiglass, 1/4 inch plexiglass, and I'm going to cut it to fit this dimension, and then I will bolt it to this and drill the holes to fit here, and I will bolt it there. Let me get some plexiglass measured up and cut. I've got this piece here. It's a little bigger than it needs to be. It's just a tiny bit bigger than it needs to be, but not by a whole lot. And I'm just gonna keep it like it is. I'm not gonna cut it up. It's perfect. Let me get this marked and drilled, and I'll come back. Well, stupid me. I'm just sitting here talking up a storm, mounting this, getting it screwed on, and thought I had hit the record button. And apparently I forgot to turn it off a while ago and turn it off when I started this. So what I've done is I mounted this box to this piece of plexiglass. You saw that part of the video when I showed you the plexiglass. I marked my holes, drilled them, and so I bolted this. I drilled more holes for this, and I bolted this to this plexiglass. It's not going anywhere, it's nice and secure. I put a really thin piece of mouse pad that I ripped the fabric off of. I put the mouse pad on the back to dampen any vibration. It's about a 1/16 of an inch thick. And I bolted this inverter to the lathe. So now it's nice and sturdy. It's not going anywhere. It took a few hours, you know, getting everything cut right and all that stuff. But now comes the daunting part. For me anyway. Not because I'm afraid of electronics. I'm an electronics technician. Avionics from years ago when I was active duty. We repaired things down to the component level. Resistors, transistors, capacitors, diodes, take them out, solder them in. I know how to solder, I know how to do all that stuff. I could probably, if I had the right equipment, I could probably fix that old inverter and replace the bad capacitor if it is one. But I don't have any of that stuff anymore. I've got a soldering iron, that's about it. Oh, and a multimeter. You can't do anything with that. Ramble on, Billy. So now I've got to figure out where all this stuff goes. Now some of these are not going to be hard. For example, the power in shouldn't be difficult. That's this one. And the power to the motor, power out to the motor shouldn't be difficult. Bob sent me a picture and a diagram showing me where these go. He also sent me a picture and a diagram showing where these go. Sort of, but as soon as he messages me back, I'll press on a little bit more. And when I figure out what I want to hook up where, I'll come back for that too. Okay, I'm going to hook a couple of wires up. But first I'm going to hook the output to the motor up. This goes to the motor. So first things first, we'll hook up the ground. Getting these big nits in tight places is not easy. And it's not that it's that tight. Got that done. T1, 2, and 3, that's these two, these three here. That's for these wires, and I believe it's white, black, red is the order. Yep, white, black, red. He said if I get it backwards, the worst thing that can happen is the motor spins the wrong way. Output to the motor's done. Now, I am unplugged, and the breaker's thrown as well, so yes, I'm that anal. Now this is L1 and L3 is your power in. And L3 is white, L1 is black, and we've got the ground. So let me pull that ground screw. So power in is here, power out to the motor is here. Now all I have to do is hook up all of these. Some of them are not difficult. So I'm going to do some research and read my manual and go through it and check the parameters versus the parameters that Powermatic sent me. And that should tell me, number one, what program notes or what program entries to make here, and also maybe what to do with these two wires for the brake. Okay, time for the acid test, or smoke check as we used to say. I plugged it in. I'm going to go turn the breaker on and see what happens. My RPM Freq meter is lit and I have power. So it looks like that is at least hooked up right. Now I'm going to go finish looking at all the parameters over and come back and start programming. Okay, these are the parameters that Powermatic sent me for how the original inverter was programmed. On its own, that doesn't necessarily make much sense. So I downloaded the manual and I went through here and correlated everything with these settings. And so that it made more sense, I circled the settings that I might need to change for this inverter. So once I got that all done and went through here, then I had to go from this manual to correlate them to the new inverter. Did I screw anything up? I have no idea. Did I get them all figured out? I hope. But there's really only one way to find out. First thing I need to do is I need to turn the breaker on and get power to this. And what I'm going to try to do is I'll try to get you guys looking over my shoulder as I go through and change the settings to program this. We want to go to 0002, so mode, that's 2. Yep, we want 1. Now we want to go to 0005, main frequency source selection, and we want to set that to external AVI. So number 2. Zero, 0005, enter. The default is 0 and we wanted it 2. Enter. Okay. Okay, I finally got it to run using this potentiometer and turning it up to 120 cycles. Takes a few seconds to get there. 120 hertz. And it runs. It should be, from where the belt is set right now, it should be going about 1200 RPM. It is not. It's only going about 1000. So I need to increase the hertz on the inside, and I'll work on that now. But at least I've got it running. I know the motor's good. Turn it back down. That's about 10 cycles. And stop. So far, so good. Let's try to increase the frequency. Mode 0012. That's at 120. Powermatic says 134. Let's see what that does. Okay, 134 cycles. The RPM gauge says 1206. So RPMs are reading right, 1206. Perfect, so far. Okay, it takes a long time to spin up and spin down, so now we will work on that. The default for acceleration and deceleration is set to 10 seconds. Powermatic uses 5, so that's 0014. And it is set to 5. That 5 seconds seems a little bit long. Wonder what happens if I take it to 3. Well, let's set 14 and 15 to 3. All right, I like that. That's not quite as long. I like it. It sounds good. So we know the motor works. We know the inverter works. Everything is set. Most of the settings are like where I put them yesterday. Now the only two settings left to deal with involve the use of the control panel versus the controls on the front of the lathe. So I've got to get those working. So I need to set 0002 to external run stop, which is number 1. Enter. And the frequency source selection also needs to be set to external AVI, and that's setting number 2. So that's 0005. And that's external AVI analog signal, number 2. So now, first thing I'm going to hook up is the potentiometer and see if I can get it to work. This is a temporary ground that I put. This goes to the ground side of the potentiometer. Yellow is 10 volts in to the potentiometer, or out to the potentiometer, and the green is the wiper on the potentiometer. Okay, I hooked these up. Blue is ground coming from the power switch. It's wired in series with the forward and reverse switch. So it's the common for both directions. Right now I've got black at S1 and white at S2. And that's actually reversed because when I put it in forward, it runs in reverse. And when I put it in reverse, it runs forward. So I'm going to switch these. And unlike before, as soon as I turn the power on, it starts spinning. And it runs at about 90 RPM. That's with the potentiometer turned all the way counterclockwise, which used to turn it off. You'd have to turn the potentiometer up a little bit to turn it on. Well, let's see if the direction thing does its thing here. Okay, power on. It is running in forward. The switch is in forward. It spins up. 1206 RPM, which is fine. I don't hear any bad hum or other noise. Put in reverse. It does fine as well. But it don't go to 0 and it doesn't go to 50 RPMs. The slowest it turns is 92. So I'll put that back in forward, turn that off, and we will adjust that. I think that's because I'm here at 10 cycles, 10 hertz. That's the frequency lower limit is 0013. Powermatic says set it at 6. So let's go 0013. Yeah, that's 10. Powermatic says 6. Now let's see what happens. That's better. It's automatically at 50. That's 56 RPMs as soon as I pull the power switch on. It says I can take this as low as 0. I don't want to take the lower limit to 0, but I might. Well, let's just do it. Well, let's take it to 3. Wow, that's 29 RPM. All right, that's 47 RPM, as slow as it'll go. And 1206, so we're good. And at 5, it's 47 RPM. At 6, it was 56 RPM. I can live with 56. Let's take it to what Powermatic wants it to be. We're done. It's hooked up. It runs. New inverter in. Lathe runs. Does great. I am so happy you can't believe it. And as my buddies across the pond say, chuffed. I'm chuffed. Took a while. Some trial and error. A lot of trial and error. The weird thing, but it was mainly because of the way that Powermatic has that front panel wired. It was a little weird. there was the on-off switch and the forward and reverse switch are in series. That's not necessarily a problem. However, they were both sharing the ground with the potentiometer, and with this inverter you can't do that, or at least not that I was able to figure out. So I had to unshare the ground and run a separate ground from the potentiometer to here. Last night when I tried that, it didn't work. I'm not sure why, but it works fine now. Now we can get on with moving that panel to this. Okay, I've got this switch plate out, and now I need to mount it to this plate that goes on the other box. That's going to be just fine. I want to put some kind of insulation between here, so I'm going to use a piece of thin mouse pad. Let me get that cut, and we will put some screws in here, and I'll use machine screws and nuts and fasten this to this. Okay, so I've taken an old thin mouse pad. You can see this one is probably 3/32 of an inch in thickness, and I've cut it to make a gasket. So the switch plate will go on here. Now what I have to do is I need to peel this hard plastic off because it's not going to seal. Okay, got the switch mounted to this plate. This gasket will go over it, and it all buttons up into here nice and neat in one little package. Now the only thing I've left to do is pull the wire through here and connect it to the back of the panel. You can see I've changed my mind about what I was going to do about the magnet. I glued these adapters in, this plug and this adapter for this. They're cemented in with PVC glue. And then I took this to the bandsaw and I cut it off and sanded it all nice and smooth. It's plenty long, it's plenty plugged, it's not going anywhere. So now what I can do is drill a hole in the bottom of this box to fit that hole and put a bolt in it. I'm going to have plenty of clearance in there for the, put a nut on it. There'll be plenty of clearance. There's plenty of clearance from the magnet to that. It'll stick pretty much anywhere I want to put it. So it'll be nice and handy and out of the way. So let's get her wired up. And silly me, I didn't hit record. I cut this to length already. I cut it sufficiently so that it comes behind the lathe and it will go into the box, and I can put the box up here. I've still got enough slack over there. It's short enough that it's not going to be a real tripping hazard, but it's long enough that it'll get me anywhere I want to go around the lathe. So now I will strip this back and prepare the ends of these. When I get ready to prepare the ends of these wires, I'll show you what I'm going to do, because they have to be, well, they don't have to be. A lot of people would simply strip the ends of the wire, crimp whatever crimping piece they're going to put on it, and go from there. I like to tin the ends of my wires, and if you don't know what that means, I will show you in just a minute. All right, now around to the front of the box. I'm going to need, there's 5 wires here that I need to connect to that go to the inverter. So this comes in 5 of these wires, and I made it extra long for a reason you'll see in a minute. One of them will go back out the back of the lathe and go to the A ground, the 10-volt ground for the potentiometer. So I need 5 wires going from the old switch wire bundle that's already wired to the inverter. I will hook 5 wires up to 5 of these wires, and they're all the same color code: blue, white, black, green, and yellow. So blue, white, black, green, and yellow will go to blue, white, black, green, and yellow. So let's get blue, white, black, green, and yellow stripped so that we can tin them. Now if you remember, this wire bundle or cable has 7 wires. More than I need, but I do need 6. 5 for the inside and 1 going to the ground. I've got green, white, and yellow done. I need blue and black. I don't have black, but I have brown or purple. So I'm going to go blue and brown. So brown will go to black because it's kind of close. And the purple, that leaves me 2, red and purple. And I don't want to use a red wire for ground, so I'm going to use this purple for ground. That said, the red wire isn't needed, so to keep it from being in the way, I'm going to cut it off. So now I've got the 6 wires that I need. I said we need to tin these wires. What that means, because if you don't, they fray easily enough. I've got them twisted together, but they won't stay that way. When you start messing with them, they have a tendency to want to do their own thing. So before I crimp ends to these, whatever ends I'm going to use, I'm going to apply some solder to these wires. And the solder wicks down inside. And this is called tinning. Okay, the wires are tinned. On this end, when I get these all cut and ready to go, I'll do the same thing. But for now, let's prepare the body for burial. Put a bolt through the magnet, through this hole, and it should be plenty strong to hold this pretty much anywhere I want to put it. Cool. This is just a big flat welded magnet I got at Home Depot. Okay, now what we need to do is we need to run these wires through this compression nut and also through this rubber compression fitting, and then into the box, or conduit body as it's officially referred. To keep this temporarily in place, I'm going to snug this up so that I've got enough room and cable to work on these connections. I've got these labeled. This white one goes to A ground, which I said is going to be the purple wire, and I will be using this spade connector for that. It goes in snug. I had to bend it a little bit, but it goes snug. And where necessary, like on this connection, once I get this one crimped in, I will put heat shrink over this. When I get them plugged together, I will heat that heat shrink, and that will ensure that wire doesn't go that connection doesn't go anywhere. It'll keep it nice and taut, so it won't come unplugged even if some stress does get put on it, which no stress should get put on it, but you know, things happen. Oh yeah, baby. Now, this is green. So what I'm going to use there, I could take insulated spade connectors, but I like these barrel connectors better, or they're called bullet connectors. So I'm going to use bullet connectors. I think I'm going to put heat shrink over that too. Better safe than sorry. Some heat shrink for the yellow one. And another bullet connector. Alright, all the connections are made. That heat shrink is good stuff. Now those are nice and insulated. I won't have any problems with them. And that's that. Connected, they're insulated, no chances of shorts. You don't have to gorilla tighten this, just get it snug to keep the air out and the dust. Now, what we do need to tighten pretty good is this compression fitting so that the wire don't slip back and forth. And you know it's tight enough when it starts twisting the wire. That's not going anywhere. One each remote box for my lathe. And it sticks anywhere I want to put it. That's a strong magnet. I'm going to put it there for the time being. It's easier to get off. Okay, now we can focus on the other end. I've got two wires that I need to tin over here. I know you can't see it. You're just going to have to trust me. What's that? You want me to move the camera anyway? Okay. You know what I haven't done? I haven't cut a plate to go over where this lathe goes. But not to worry. This I shall do. I've got an external template for it right there. I just have to figure out what I want to make it out of. I don't know what I'm going to use yet. I hadn't figured it out. Alright, I'll move it. Put some solder on my iron. Move my light over here so I can see what I'm doing. Now, when you're tinning wires or making a soldering connection, you don't stick the solder to the iron. You stick the solder to the wires. When they're hot enough, it'll wick in. You do it before then, and you try sticking the iron, the solder to the iron, it's just going to stick to the iron. And if any of it does stick to the connectors, you're not going to get a good connection. We got those done. Now we need to cut back and strip some of these. Before we do that, remember, purple is my ground, right? Isn't that what I said? So I'm going to run it back out this hole. And I can. I've got this out. That's good. There's enough length for it to go through and then some. So what I want to do right now, that's plenty. All right, I'm going to strip these and tin them and I'll be back. Okay, got them tinned and I've got the connectors on. Now, you may be asking, Billy, why didn't you just put new connectors on everything? Because if I'm able to get the old inverter repaired, I will. And if this one ever fails, I'll have a spare. And then I can just hook it up the way it came out. So, white to white. Heat shrink on that just to make sure that it doesn't do bad things. I don't want to take any chances on any shorts. Blue goes to blue. I'll heat shrink that. White goes to white. And I'll heat shrink that. Brown goes to black. And I'll heat shrink that. Green goes to green. There's no metal showing. Yellow goes to yellow. And there's no metal showing. Heat shrink to blue. Now we're all connected over here. Push this excess through. I don't need a whole lot. And put these in here. And I'm doing this to keep them. I don't want a bunch of excess wire stacked up in here because it'll get in the way of the spindle and the belt. And that would be a bad thing. So this is just about right. Before I make this cover spot, I'm going to go hook up that last wire, my potentiometer ground. Okay, I've got all the wires hooked up. Let's turn it on and see what happens. Bring my control over here. I've got the right signals on the lathe. It comes on. And 1206 RPMs. It's relatively quiet. It's not any louder than it ever was, which is a good sign. That means things are working right. All that's left for me to do is make a cover and put on, and my big boy is back in business. So it's done, and it works. I'm back in operation, got a new inverter on it. Cost me about $500 less than had I ordered one from Powermatic, and I wouldn't be back running until at least mid-November. So I can't complain about that. The inverter is a Westinghouse. I'll put all of this information down in the description below. If you have any questions, feel free to let me know. I am by no means the expert on doing this sort of thing. I'm just the first one to do a video on changing an inverter out on a Powermatic, so far as I've found. A lot of people have done it, and some people have documented it, sort of. But I really want to thank fellow Texan Bob Fleming for the information on this particular inverter and where to get it. And I want to thank him for all of his help and suggestions, and more importantly, I want to thank him for the couple hours of troubleshooting that he and I went through over the phone. Because when I first hooked this thing up, I just hooked things up the way they were hooked to the old inverter. The way this particular inverter works, it doesn't work that way. You have to do something a little bit different. And it took me a little bit to figure that out. But setting the parameters were not that difficult. It really wasn't. And if you watch Cloth 42's video, I'll put a link to that up here. If you watch his video on how he set his up, he did this on a new motor install and a new inverter install on a Harbor Freight metal lathe that was not variable speed to start with. It is now. He put a new 3-phase 2 horsepower motor on it and this inverter, and he goes through the process of showing you what settings that he changed and why and what he does there, and that was a big help as well. So thank you all of you for your patience and sticking with me. No project out this week, and I'm going to be a day or two late getting this video out, but I'm back in business, and hopefully next week I'll have a project. We'll wait and see. I've been told the boss has told me that I have got to get that kitchen island finished before Thanksgiving, because this is our family Thanksgiving. So very, very soon I'm going to start working on that, and I don't know if I'm going to video all of it or just some of it or what. It's going to be a pretty extensive project. So more to come on that, building the kitchen island for the house. And I'll try to get something knocked out turning wise real soon. Thanks again. Please support my sponsors. If you wish to help support this channel in any way, the links are in the bottom. You know the spiel. Amazon affiliate link, my website where you can buy things. I appreciate it so much. I really do. And thanks again to everyone for all the well wishes for me and my family. It means so much to me. I can't explain it. I have no words. Thank you so much. I'm humbled. I really am. And remember the 3 L's. Live, laugh, and love. Y'all come back.